Hey guys, this is Professor Janacek, and I want to go over an example where we find extrema and saddle points for a function and several variables. So let's determine all the relative extrema and saddle points for f of xy equal to x squared plus xy squared minus 2x plus 1. So to begin with, we'll need to find the first partial derivatives. Critical points are when the first partial derivatives are either equal to 0 or they do not exist. So let's figure out what those first partials are. The first partial with respect to x is 2x plus y squared minus 2, and the first partial with respect to y is 2xy. Now, I do notice again, it's when these two partials are either equal to 0 or they do not exist. I notice that these two are defined for all x's and y's, so I don't have to worry about the part where they don't exist. I just need to set them equal to 0 and solve from there. So let's go ahead and set each of these to 0. And then we'll solve this system. Now, one thing I notice with this is that if I have 2xy, I can replace it with 0. And over here, I almost have 2xy. It just needs a y attached. So let's go ahead and multiply this first equation by y on both sides. That gives us 2xy plus y cubed minus 2y is equal to 0. And now we simply replace the 2xy with 0. So we get 0 plus y cubed minus 2y is equal to 0. All right, and this stuff that's left, the y cubed minus 2y equal to 0, we can factor this. Y times y squared minus 2 is equal to 0. This gives us that y is equal to 0, or y is equal to the negative square root of 2, or y is equal to a positive square root of 2. Well, for y equal to 0, we could evaluate that. Again, we're going to just use a simple substitution. Y is equal to 0. I'm going to use it in this equation right here. Replace the y with 0, and we get that x is equal to 1. For y equal to a negative square root of 2, again, replace the y here with a negative square root of 2, and in that case, looks like we would get x is equal to 0. Similarly, when y is equal to positive square root of 2, again, replace the y there in that first equation with a positive square root of 2, and again we get the x value is 0. Thus we have the points 1, 0, 0, negative square root of 2, and 0, positive square root of 2. These are the critical points. Now we just have to figure out what happens at each of those critical points. Well, first thing we'll need to do is find this discriminant, but that includes the second partial. So let's go ahead and find all of the second partials. If we find the second partial with respect to x, that is, again, we're looking at this one and taking the derivative again with respect to x. That gives us 2. And take a look at that same one, but now take the derivative with respect to y. That gives us 2y. Now if we look at this one, oops, not that one, this one, and we'll take the derivative with respect to x now, so f sub yx, that gives us 2y. And then looking at that same one, we'll find the second derivative with respect now to y. And that gives us 2x. All right, and again, I write it in this particular form because we want the discriminant of that. So the discriminant of xy is, if I set these values up as a matrix and then take the discriminant of that matrix. So the discriminant of 2y, 2y, 2x, which is 2 times 2x minus 2y times 2y. Of course, if you don't remember how to find the discriminant, you can simply use the formula that we have up there. F sub xx times f sub yy minus f sub xy squared. Either way, you should end up with the same thing. We end up with d of xy is equal to 4x minus 4y squared. Now all we have to do is evaluate this at each of those critical points. So the first critical point, 1, 0, let's see what happens there. If we evaluate this at, if we evaluate 4x minus 4y squared at 1, 0, looks like we get a 4, which is positive. And so we're looking at either this case or this case when that discriminant is positive. So all I have to look at now is what's going on with f sub xx at AB. Evaluate f sub xx at 1, 0. Well, here's f sub xx. At any point, we get just a 2, which is also greater than 0, so I think that tells us both of those are greater than 0. There is a relative minimum at that point. So there is a relative minimum at the point 1, 0. All right, how about our next point, 0, negative square root of 2? Again, we're evaluating our discriminant at 0, negative square root of 2. I think when we evaluate that one, we end up with, watch that negative there, it ends up being a negative 8, which is less than 0, which tells us the discriminant less than 0, we have a saddle point. And finally, our last point, 0, positive square root of 2. Again, evaluate x with 0 and y with square root of 2. And it looks like, again, watch that little negative. Make sure you don't lose that there in the middle. We end up with, again, a negative 8, which is less than 0. And again, here we are, less than 0. For that discriminant gives us a saddle point. So there is also a saddle point at 0, positive square root of 2. And there you go. Enjoy!